We're going to take a look at the 2012 question 1, the linear motion question from that year. Let's take a look at the part A then. It says a particle falls from rest from point P. When it has fallen at a distance of 19.6 metres, a second particle is projected vertically downwards from P with initial velocity of 39.2 metres per second. The particles collide at a distance d from P. Find the value of d. So if we take a look at this question, there are two separate things happening here. We have one particle that is falling first and then a second particle. They've only given us information about the first particle. So what I'm going to do is I'm going to use that information to find out as much as I can about the first particle, and then I can try and tie both of them in. We know that if the particles are going to collide, then that means that their distance is going to be the same. So I'm going to use my S formula and try and find where the distances are the same. So first thing I'm going to do is going to write down everything I know about these different particles. The first particle then, I know, if I call that particle 1, I know that it starts from rest. I know that I don't know what its final velocity is. I know that its acceleration is going to be 9.8 because it is dropping from a point. My distance then, I know in my first section the distance is 9.6 and I don't have a time. So let's go find some information out about this one. The first thing I'm going to look at is I'm going to use v squared equals u squared plus 2as. And when I substitute into that, I'm going to get v squared equals 0 squared plus 2 times 9.8 times 19.6. So v squared comes out to be, I'll just go with v. V comes out to be 19.6. So that means that 19.6 meters per second is how fast it's going when it's got a distance of 19.6. The next thing I'll take a look at is the time then. So it's going to be v equals u plus 80. That's going to be 19.6 is equal to 0 plus 9.8 times t. So t comes out to be 2 seconds. So that means that I now know that particle 1 is dropped and 2 seconds later particle 2 then is vertically projected downwards. So now I'm going to take a look at particle 2. So particle 2, it tells me that I have an initial velocity, so my u value is 39.2. The v value, we don't know. Acceleration is going to remain the same as 9.8. I don't know how far they have to go, and I don't know how long it's taken. So now for this second stage, I know that the time for particle 1 and for particle 2 must be the same, and so is their distances. So my new S value will be the same as this value here for section 2 of the particle 1's journey. And then the time for this is going to be the same time for this, except it's going to add on 2 seconds. So my t value now for my particle 1 is going to be t plus 2. Because I know this went 2 seconds earlier than this one. So in its journey, it is doing t plus 2 times rather than t on its own. So what I'm going to do now is I'm going to create an equation in terms of s and in terms of t so that I can say, well, I know that I'm looking for when the distance particle 1 has gone is the same as the distance that particle 2 has gone. I'm going to use my S formulas. And my S formula is S equals ut plus a half at squared. So for particle 1 then, I know I'm going to have S, which I don't know, is equal to u is going to be 0. That's the starting speed of it. T is going to be t plus 2, because that's going to be the time that it's taking for particle 1 and particle 2 to meet, plus 2 seconds because it had a time of an extra 2 seconds. Plus a half, my A value is going to be 9.8, and my T value then, again, same as earlier, is T plus 2, and that's squared. So that's my first particle. My second particle then, using the S formula, is going to be S equals, my U is 39.2. The time here is T because that particle is moving at a time of T in comparison to this particle, which was moving at a time of t plus 2 seconds. Plus a half, my A remains at 9.8, and my time again is t and that's squared. I know that these two have the same distance. I'm looking for when their distance is the same. At what time is their distance the same? So I'm going to let these two particles equal. So when I move this down, I am now going to let these two particles equal, and I will have 0 times t plus 2 plus a half times 9.8 times t plus 2 squared. When is that equal to 39.2t plus a half 9.8 and t squared? I know this is going to go this first section, and when I multiply out this, I'm going to end up with 4.9, and that's going to give me t squared plus 4t plus 4 equals 39.2t plus 4.9 t squared. So I'm going to divide all these different parts by 4.9. So I'll be left with t squared plus 4t plus 4 is equal to 8t plus t squared. The t squares on both sides will cancel. I'm going to bring the 4t over here so that I end up getting 8t take away 4t, which is 4t, is equal to 4. So the t value is equal to 1. So that means that when I projected, or when the second particle was projected, it took 1 second before the two particles ended up colliding. The last thing I have to do is go back and check and see what was the question. I have the question over here. Find the distance. So I want to see what the distance was. The particle collides at distance from P. Find the value of D. So I'm going to take one of the equations. It doesn't make any difference which one it is. I'm going to substitute in the time of T. So if I take this second equation here, I'm going to see how far that second particle went in 1 second. And in goes my 1 for t. Put the whole thing into the calculator and I'm getting 44 meters. So that is my answer then done for the first question. The second question then, part B. I'm going to just move this down so we can start a bit further down with it. And we're just specifically looking at part B. So part B here, it says that we have a car starts from rest at A and accelerates uniformly at 1 meter per second squared along a straight level road towards B, where AB is equal to 1,914 meters. When the car reaches its maximum speed of 32 meters per second, it continues at the speed for the rest of the journey. At the same time as the car starts from A, a bus passes B, travelling towards A with a constant speed of 36 meters per second. 12 seconds later, the bus starts to decelerate uniformly. We're looking for the car and the bus meet after t seconds. Find the value of t. Find the distance between the car and the bus after 48 seconds. So if I'm looking at this question here, this is very similar to the 2019 question. We're talking about two different vehicles that are heading towards each other, and it's checking to see how long it takes for them to meet. What we need to do here then is we need to draw our distance, speed and time graphs. And what I'm going to do is I'm going to create two separate little ones to take in the two different cars. So for the first car then, I'm going to look at its car A. And car A, I know that car A it starts from rest. I know it has acceleration of 1. It has then a V value of 32, but that's its maximum volume. That's its maximum velocity. So if I'm going to draw a graph for car A, I know that what's going to happen here is I'll have my graph. I know I'm going to start at my point. I'll go up a certain amount and then I'll end up going straight across. This point here is going to be 32, and I can split this up into two different sections. So that is going to be the section where you are accelerating and then the maximum velocity section. For car B then, the information we have about car B is that our Starting speed is 36. It continues doing that for 12 seconds. So I know then if time is 12 seconds, I'm just going to use distance, speed, and time to say that my distance is equal to my speed by my time. So the S value in that first section is 432 meters. After that, then it starts to accelerate. So in a new section, then it starts to decelerate. Its U at that stage will also still be 36. Its V will end up being 0. Its acceleration is minus 0.75. And then I draw my graph for that. And again, I have my 36 here. I know that there's two separate parts to this. Inside here, the car has gone 432 meters, and that has taken them 12 seconds. So I know that the distance from here to here is 12 seconds. Going back then to my first section, I can go and find out all the information that I need for my time. So I'm going to use my my V equals. And using that, I have 32 equals 0 plus 1 times t, meaning my t must be 32 seconds. That means that this takes 32 seconds. Now what they're asking us to do here is they're saying that the car and the bus meet after t seconds. So if we look at this part here is taking us 32 seconds. This here is taking us 12 seconds. We know that the whole distance that they are going is 1,914 meters. I know in this section here that we've gone 432 meters. And I know in this section here, we have gone a distance of the area of this shape. And the area of that shape is going to be 32 times 32. And 32 times 32 divided by 2, which is going to give us 512. So that's 512 meters gone in that section. And I'm just using the area of a triangle to do that. So half 32 times 32 to give 512 meters. That's the distance. So if I add those two sections together, I can see that I amn't anywhere near this 1,914. So that means that I am outside of this 12 seconds and I'm outside of this 32 seconds. So they're meeting while this car here is decelerating and while this car here is going at its constant pace or its maximum velocity. So that means now that what I'm looking at in terms of t is I'm looking for when the two times or the two distances add to give me my overall distance of 1,914. So I'm going to get these in terms of time and I'm going to try and add them together to give me a distance of 1,914. So I want to find the distance of the first and the distance of the second and see when those distances add to give me that. And it's going to all be in terms of time because I don't know time. I do know that this section here is included, which means that this section here is going to be 32 minus t seconds. And I know then that this section here is going to be, same idea, it's going to be t, but it's minus 12 seconds. So when I go to fill in these formulas, what I have to do is I have to get my distance of the first one, and my distance of the first one is going to just be the 512, and then I have to add on the distance of this section here. Now there's several ways to find that distance, but what we can do is, because it's constant and because there's no deceleration here, the easiest thing to do is to multiply 32 by this, and that will get me the distance under that curve. So all I'm going to do here is I'm going to use the area formula. That's 32 multiplied by t minus 32. And the reason why I can use that is because I know what's happening in this section here, and it's not accelerating, not decelerating. There are other stages where you can use the formula S equals u plus v over 2 times t. That formula can get a little bit confusing, so I would try and stay away from that formula. And you will see that formula used in different solutions. but getting the area underneath the curve is probably the easiest way to do it. So that's my S1. My S2 then, because we are now using this section, we need to figure out how much of this section we're using. And to do that, what we're going to do is we're going to use the S equals UT plus a half AT squared formula. Because there's a section of deceleration, we can't specifically use the area formula for that bit because we don't know how much of it is going to be used. So what we can do though is still, we know that all of this area is going to be used up. So what I can do is I can say, well, I know my 432 will be there, but the remaining bit, this section here, I'm going to find using my S equals UT plus a half AT formula. So I have my 432, and now I'm going to go ahead and I'm going to use my S equals. So my U value for this, if I pull this down a little bit, my U value is going to be 36. My time, I know is going to be T minus 12. Plus a half. My acceleration or my deceleration in this case was minus 0.75. And in for my time, same as the last one, minus 12 and squared. And I know that this whole thing here should add to give me the total distance. And we know the total distance, it's up in our question here. It's equal to 1914. So all I've done there is I've created my two little diagrams using all of my information above. And now what I'm doing is I know that I can use the area formula for this one. And I can use the area formula for this one. But because I don't know specifically how much of that triangle is going to be used, I'm not using the area formula for that. I'm going to be using my S equals UT plus a half AT squared. All I'm doing from here is I'm solving this equation as if it's algebra. So when I'm solving this equation, I'm going to take this, and I'm going to bring them across, and I'm going to minus them on the other side. So that I know then on the other side, I'm going to end up with 970. On this side here, when I multiply this out, I'm going to get 32 times t is 32, t. Minus 32 times 32 is 1024. Plus that's already been used. I've already brought that across, and I've brought this across, this 512. The next thing I'm multiplying out is 36 times t, which is 36t, minus 36 times 12, which is going to give me 432. The next one then is going to be then minus 3 over 8. And when I square out that bracket, I'm getting t squared minus 24t plus 144. And again, all I'm going to do here is I'm going to tidy everything up, and I'm going to see what I'm left with. This is going to come across, and it's going to subtract from the 970, or what I can do is bring everything to one side, and then I can let them equal 0. From there, you're just using the minus b formula. So I'm going to multiply this out and add everything together that I can. So I'm going to add my t's together. I'm getting 68t. I'm going to multiply out my bracket here, and I'm getting minus 3 over 8t squared plus 77t plus plus 9t, no, I'm doing wrong there, sorry. 3 over 8t squared plus 9t, and then finally minus 54. So that's that all multiplied by that. That then equals, I'm going to bring my minus 1024 across. It's going to add to the other side, and I'm going to be left with 2426. Everything to one side then. I'm going to bring everything to the right hand side to get my minus 3 over 8t to be a plus. And I'm ending up getting 3 over 8t squared minus 77t plus 2480 equals 0. I'm going to substitute everything into the minus b formula. And when I do that, I'm getting t to equal 40 seconds or to equal 165.3. You're going to go for the lower one because that's the one that we're going to meet them at that time first of all. And that is my answer then for that section B, part 1. So the last section then, it says find the distance between the cars and the bus after 48 seconds. All we're doing there is we're using our S formulas, and our S formulas are written here. There are two S formulas. I'm going to substitute it in there and I'm going to add them together. And when I add them together, what's going to end up happening then is I'll end up then having to subtract my original distance because it's asking the distance between the car and the bus after that. So I'm going to substitute in my value of, they said 48 seconds. I'm going to sub in 48 seconds into that top thing there. And when I sub that in, I am getting 512 plus 32 times 48 minus 32 plus 432 plus 36 times 48 minus 12 plus a half times minus 0.75 times 48 minus 12, and then that's squared. All of that goes into the calculator and I'm ending up getting there 2266. I have to minus my 1914 away from it to find how far of a distance there is between the two. And we're getting 352 meters altogether. So that is that question done. So just with those ones, make sure that you're drawing out your two graphs and just use the distance underneath the graphs rather than using any other formula. It makes it a little bit easier to see what you're doing. So draw out the two graphs. You're looking for the distance underneath them. And just make sure if you're decelerating at any stage like we were here, that you're using this formula rather than just your area, your specific area formula.